So class, what's 1 times 1?
1.
And then 1 times
5.
4. Because 1 plus 4 equals 5. And 5 is the degree of the polynomial. Class, how many dots is this going to be?
4.
No, 2.
4. We just wrote down the real tells us the number of dots. So 1 real is 1 dot.
Wait, 1 dot. Wait, isn't it 2 dots?
And this one where it says 1 real will also be 1 dot.
Okay, it is the same thing. That's what I'm saying.
Class, where are the arrows supposed to be?
Down.
Yeah, they cannot say both up. They have to be an opposite. So you could pick either starts up, ends down. Yesterday we learned that you're going from left to right, so starts there and ends here. And basically as we draw, make sure you're using pencil. We have to end up on the next one. So I'm going to start here. Class, is this an odd or an even multiplicity? That one's an odd. Yesterday we learned that an odd multiplicities, it does what? Odds is going to go through the x-axis. Let's go draw it through. Multiplicity of 4, even or odd? This is an even. We're going to bounce or kiss off the x-axis. So you have to make a turning point. Okay. Now, let's see if you get the big idea. Tell your partner what's wrong with my graph. 10 seconds. Something's wrong with this graph.
It's looking all funky. The Funkasaurus.
I'm going to point to something on my formula sheet. Will that tell us what's wrong with our graph?
Stop.
Class, what is this called? That's called an extrema. So if I look on my formula sheet, extrema, the most number of extrema equals a degree minus 1. Or they also call those turning points, right? So if I write down that formula, class, we've been working on what type of function? What does it say at the very top? Quintic has a degree of 5. So if I put in 5 for my degree, class 5 minus 1 is 4. So I need to have 4 extrema, or 4 bumps. 4 total of valleys and peaks. How many do I have? Count with me. Ready, set, go.
1, 2.
So what do I need to do?
2 more. Wait.
One, 2, 3, 4. And those represent how many imaginaries do you have? 0 imaginaries. That's why it doesn't touch the x-axis. Question? Yeah. On that problem up here, she's asking in our example. I'm not sure if we ran out of time or not. Thank you to Angel for pointing that out as well. We should have 4 bumps in there, so you can do something like this, and then have it just do a bunch of squigglies. 1, 2, 3, 4. So this would be a more accurate graph. Alright, let's go over G. Girls, 1 times 1 is?
1.
So 1 real. Girls, what number goes in there? 4. So 1 plus 4 equals 5. Girls, how many dots am I going to have here? Just one dot. And girls, where should the arrows be? Where do you want to start? Someone said down. Therefore, the next one has to be up. Girls, as I start here from left to right, what do I do at the pink? Do we bounce or go through? Go through it. Okay, girls, how many turning points or extrema do I need to have? 1, 2, 3, 4. Now, some information that we did write. We wrote that imaginary zeros, this is an imaginary zero, they come in what? Pairs or twos. So if you notice, we have 4, 0, 2, 4, 0, 11 to 4. Okay? How do you think that's going to help us for the next problem? Boys, what's 1 times 1?
1.
So I have 1 real. Boys, 1 times
2.
Oh, we're not sure, right?
2 is 2.
1 times 2 is?
2.
So that's 2 reals. That means this number has to be what? 2 imaginaries. Because 1 plus 2 plus 2 equals 5. This number has to be a 0 or a 2. Now, if you did say that was 0, then I guess you could say that this one could be a 4. That would work. Boys, how many dots is this first one? So 1 real tells us the number of dots. So we have 1. Boys, this next one, number of dots. 1 dot, 1 real. Boys, where do my arrows start? Someone said up, down. Boys, what happens as if I start here? What happens at the pink? It's an odd, so we go through it. Boys, what happens at the green? And boys, can I just go to the arrow there? Yeah, more bumps. More extremas. So I have 1, 2, 3, 4. So in this case, the arrows, people have been asking, our end behavior does not matter.